Hello students, this is an online session. This was arranged within a very short period of time. It was an immediate action due to the current situation in the country. So this session we have a lot of ups and downs because I don't have a proper lighting or sound system. This was done with a very minimal arrangement due to the time factor, because the O-level students, you all just have around 250 days. Keep this in mind, you have 250 days. Whatever happens, your O-level is going to happen on the exact date. On December first week, your O-level is going to happen. Days, your O-level is going to happen. So keep that in mind. So each and every minute, each and every second counts. So because of that, in order to cover the syllabus within the given time, we planned of starting this kind of temporary measures. So every minute counts, every second counts, so you have to do your work. Just because of the problem, don't think that your O-level is going to get postponed, your O-level is going to, they are going to make the exam paper easy. No, they will be adding more questions related to this current pandemic situation. So your exam is going to be more tough, because you have got a lot of time to stay at home and study. That's what the argument they will be saying. So O-level students, keep this in mind. Please do your work. So this online session, this YouTube session will be I will be explaining the theory and all the needed things will be written in the board. I hope the board is clear. If you all have any problems, anything related to that, you all can comment and give me personal calls or anything like that. So if you have the tute with you, I hope you have the optics tute. So today's topic will be optic. If you have the tute, you go along with the tute. Okay, so we'll start. Today we will be starting the 5th unit of grade 11. 5th unit of grade 11, that is geometrical optics. I hope you all can see the topic. Okay students, the first thing we are going to study under this section is to see something. For you all to see this board or whatever I write in this board, two things are essential. First one is light, the other one is sight. Light is also needed, sight is also needed. Why is that? For example, now let's say there is a box. You can see the box. Yes. That means because of your sight you can see the box. But what if all the light is off? It is in total darkness. You won't be able to see the box. It will just be dark. So in order to see this object, there should be a light source. Sun or a candle or a star or a bulb or whatever, a luminous source. Object which produces its own light is called luminous object. Object which cannot produce its own light is called non-luminous object. So to observe a non-luminous object, there should be a luminous object. There should be light emitting from that. What happens? The light comes and falls on the non-luminous object. From there the light is reflected back. Because of that you can see the object. Okay, how can you see colors? For example, now this is red. Yes. And this is, let's say, green. I hope you all can see the colors well. This is red and this is green. How can you see that this is red and this is green? How can you differentiate it? It is because the marker has the red pigment. Yes, the marker has the green pigment. Because of that you can see. But what will happen if I off all the lights and it is In total darkness, can you differentiate the color? No. Why is it? That's because, listen, the luminous object emits white light. White light. White light means it is the combination of violet, indigo, blue, green, yellow, orange and red. VIBGYO. All this VIBGYO color comes to this object, falls on this object, and here at this point, because of this red pigment, all the other colors are absorbed and red pigment is reflected back. Red light is reflected back. Therefore, you can see it as red. In this situation, the VIBGYO white light falls on this object, all the colors are absorbed, but the green color is reflected back to your eye. Therefore, you can see it as green. If there is no light source, if it is in total darkness, no color is reflected back to your eye, therefore you cannot differentiate the color. So did you understand? To see an object, to observe an object, you need light and sight, and to observe the color difference, you need white light coming and falling on the object and reflecting back. This is the smallest introduction to optics. Yes. Objects can be either luminous or non-luminous. Luminous objects can emit their own light. Example, stars, sun is also an example. Candle light, electric bulb, or whatever light source. Non-luminous objects, all the other things, pen, marker, board, whatever, is non-luminous object. It cannot emit its own light. Also, objects can be divided into three categories. For example, some objects are transparent. Transparent objects allow light to pass through them without any deflection or without any refraction or reflection. Without any disturbance, light rays passes through transparent object. Clear sheet of polythene, a thin glass, all those things are transparent. The next thing is opaque. An object which is opaque will not allow the light rays to pass through this. For example, this blackboard. The one who is behind this blackboard cannot see what is in front. Or for example, I cannot see what is behind the blackboard because light rays from there cannot pass through this blackboard. It is called opaque. The next one is translucent. In this type of object or in this type of material, light passes through, but it is deflected, it is changed. The pathway of the light is changed into many directions, so we do not get a clear picture. For example, decorated glasses. You can see that someone is standing behind the glass, but you cannot see who it is, or you cannot differentiate. So light passes, but not directly or not. You can say that there is a deflection when the light passes through translucent object. So the students who are noting it down, please note down what is transparent, what is opaque, and what is translucent. You all can pause the video and write the definition and go to the next thing. Okay. Light passes through some material without any hindrance. These objects are known as transparent objects. Light does not pass at all through some objects. These objects are known as opaque. Light passes through some material with irregular changes of direction, making it impossible to see the object on the other side clearly. That is translucent. Yes, thank you. Yes, now in physics, to represent, we can see light, but we cannot see how it travels. So to represent that in physics, we draw a straight line with an arrowhead. This represents one light ray, and the arrowhead represents its direction. If it is one single line, it is called a light ray. If it is many single lines, it is called a beam of light. Beam of light. When considering beam of light, if all the lines are parallel, it is called parallel beam of light. If all the light rays go towards one point, it is converging towards this single point, then it is called converging or convergent beam. Or if the light rays seem to be emitting from one point and getting scattered throughout, it is getting dispersed or it is getting diverged, it is called as diverging beam. So when representing, later we will be representing light rays beams. If it is parallel to each other, it is called parallel beam. If it is converging towards one point, it is called converging beam. If it is being diverged from one point, one single point, it is called diverging beam. You all please pause the video and copy all these things. In optics, we have two sections. The first one is reflection of light. I hope you all can see. Reflection of light. The next section is refraction of light. Reflection of light, refraction of light. Reflection of light is mainly based on mirrors. Refraction of light comes under lens. So this video session will be mainly targeting a reflection of light. The next session will be on refraction. It is a long chapter where we talk about all the types of lenses, Here we are going to talk about all the types of mirrors and how the images are being formed. So when you take mirror is just a block of glass. When you coat one side of the mirror with one side of the glass with mercury or some other kind of material, what happens? This surface, the opposite surface, becomes a reflecting surface. Therefore, when light rays come, it gets reflected. So you take a piece of block of glass and paint one side with mercury or some other materials, then it automatically becomes a mirror. So this is called a plane mirror, because there is no angle, there is no curvature. It is called a plane mirror. There are certain mirrors which are curved. One type of that, if this surface is painted with mercury, this surface becomes a reflecting surface. If the reflecting surface is curved inside, curve එකක් cave එකක් වගේ curved inside, it is called concave mirror. Take another glass and apply mercury. This is the mercury surface. This automatically becomes the reflecting surface. The reflecting surface is bulged out, therefore it is called as convex. So we have plane mirror, concave mirror and convex mirror. Yes, now we are going to talk about reflection. Let's take a plane mirror. This is a plane mirror. This is the mercury surface, this is the reflecting surface. If a light ray is directed towards this mirror, if a light ray is directed towards this mirror, this light ray will be reflected. So the ray which is coming towards the mirror, it is called incident ray. Incident ray. Once it falls on the mirror, it gets reflected. Therefore, this ray is called reflected ray. So incident ray, reflected ray. The point where this incident ray falls, the point of incidence, we draw a perpendicular line perpendicular to the mirror, a line perpendicular to the mirror at the point of incidence. At this point we draw a line which is perpendicular to the mirror. This line is called normal. Light ray comes at the point of incident, it gets reflected back. Incident ray, reflected ray. At the point of incident we draw a line. That line is perpendicular to the mirror. It is called normal. Yes. Then we can draw two angles. The angle between the incident ray and the normal is called incident angle, short symbol I. And the angle between reflected ray and the normal is called the angle of reflection, angle of incidence and angle of reflection. Normally here it is, the drawing is little bit smaller, not proportional, but if I draw it in a square rule book in a proper way with the proper angles, incident ray and reflected ray are equal. If this is 60 degrees, this will be 60 degrees. If this is 30, this also will be 30. Therefore, they made two laws. First law of reflection says that incident ray, the reflected ray and the normal drawn to the point of incidence all lie on the same plane. Now this board is the same plane. One ray can't come like this and just go somewhere else with a different angle or different plane. It has to come along this plane, get reflected and go along this plane. It can't come straight like this and come out of the board or go into the board. It has to pass this way because all these lie on the same plane. Therefore, the first law of reflection says that incident, you all write it down, incident ray, reflected ray and the normal drawn to the point of incident. Very important, you can't just say normal. Normal drawn at the point of incident. all lie in the same plane. That is the first law. Next time I meet you at class, I will be checking all this. Just you can't just look at the video and just enjoy and just leave it. You have to copy down all the needed points. I will be checking this, so please note the point. Yes, first law done. Second law of reflection, not refraction, reflection. First law of reflection, second law of reflection. Second law says, it is very simple, angle of incidence is always equal to the angle of reflection. Angle I is equal to angle R. Angle of incidence is always equal to angle of reflection. That is the second law. So we have started reflection, plane mirrors, and under mirror we have two laws. Under reflection we have two laws. First law of reflection, incident ray, reflected ray, and the normal drawn to the point of incidence lie on the same plane. Second law states that angle of incidence is always equal to the angle of reflection. I hope you all have understood. If there is any doubts, you can comment on the section below, or you can give me a call and clear your doubts. Our next topic will be images formed by plane mirror. This is a very, very simple theory. Okay. For example, look at this. Now let's say there is a mirror like this. If there is an object here, this is the object. Now we are going to draw a point object, and a man observes this object through the mirror. Where will he see the image? He will see image behind the mirror. If he goes behind the mirror, can he see that object? No. Is there an object like that behind the mirror? No. But when he looks into the mirror, he can see as if the object is inside the mirror. If he peeps to the other side, nothing like that. So it is a virtual image. Virtual images cannot be taken, cannot be projected into a wall. There are two images. Later you will be studying real image and virtual image. Virtual image is virtual. You cannot take it to a screen. You cannot make it fall on a screen. But real images can be made to fall on a screen, and you can see the image on the screen. But virtual images, you can observe it only through the mirror, as if it is inside the mirror. Yes. How is the image formed? For this, we will need two light rays. There are thousands of light rays emerging from this point object, but we are just going to consider only two light rays. This, I don't know the location. We will consider this light ray. Now, this point is emitting light. It falls on the plane mirror. Our plane mirror theory, we draw the normal at the point of incidence. This is the normal. This angle should be equal to this angle. Now we can draw the reflected ray. Yes. This is the reflected ray. Incident ray, reflected ray. Incident angle, reflected angle. This is one. Then I am going to draw another ray. Where shall I draw it? Yes, somewhere here. A ray which is coming, falls on the mirror, incident ray. Then we draw the normal, incident angle, reflected angle, and this is the incident angle, reflected angle of this ray. Reflected ray. So a person who is observing from here the rays don't meet. Now here the lines are not straight. You all can use rulers and draw the lines properly. So how is the image formed? A person observing from here will see as if the image is here. So if the lines don't join, image is not formed. So line is not joining in this direction, so we draw lines to this side. It should be, you have to keep a ruler and draw it. When you keep a ruler and draw it, you get it properly. And this, it is coming this way. Yes. Yes. Incident ray, reflected ray. It's from the same point. Another incident ray, reflected ray. They don't meet, but when we extend the line behind the mirror, they meet at a point. So this meeting point is the place where the image is formed. Image. This is the object, this is the image. The image is formed by the dotted lines, not due to the straight lines. Therefore, it is a virtual image. Real rays do not meet, but the extension of the real rays, they meet. Therefore, this image is considered to be a virtual image. When you take the distance from the mirror to the object, the distance from the mirror to the image, both this distance will be same. This distance and this distance will be same. So those are few similarities. Image distance, this is called the object distance, this is called the image distance. Object distance is equal to the image distance. Object size is equal to the image size. Object's direction is equal to the image direction. If a person is standing upright, the image will also be upright. Therefore, the features of the images formed by plane mirror. If you all can't see it, please try to zoom it. If there is option, I will try to zoom it in the video. If possible, you all pause it and you all try to draw it. If you all draw the proper angles, you all can get the exact location. This is the mirror. In the textbook, this image is given on the horizontal, lateral view, vertical view. I have given it horizontally so you can understand. Object is here, this is the mirror, a person is observing from here. The person will see as if the image of this object is somewhere here. So we have to find the place. Yes. Then note down the characteristics of the image formed by plane mirror. First one, no rays actually pass through the image because there is no light ray at the location of the image. Therefore, this image cannot be projected on a screen. There is no real light rays. Real light rays are getting reflected, but the extension is meeting. Therefore, images of this nature is known as virtual images. Virtual image. Third point, all images formed by plane mirror are virtual and upright. Fourth point, distance from the object to the mirror, object distance, is equal to the distance from the image to the mirror, image distance. The final one, images formed by a plane mirror are identical to the object in all aspects except that the image is laterally inverted. That means that the right side of the object appears as if it is the left side and vice versa. That's a very simple thing. You go in front of the mirror and raise your right hand. Look at the mirror, look at the image. Which hand is the image raising up? It will be the image's left hand. I hope you all can understand what I am saying. To do this, to understand this, go in front of the mirror and just raise the hand. If you raise your right hand, the image will raise its left hand, which means this situation is called as laterally inverted. Yes, this situation is important in certain very few instances. For example, the word ambulance is written laterally inverted in the front view of a ambulance. It is because a person who is, now let's say the ambulance is behind me and I am driving the car here. If I am viewing the ambulance through my side mirror, then my side mirror will show. If it was written as normal ambulance, my side mirror will show it laterally inverted. Then it will be in some other format. So therefore sometimes I might not be able to identify that it is ambulance. I might not give way. So they already, while printing, they already make it laterally inverted, so that when I am viewing it through my side mirror, it is already corrected. I can see the proper word ambulance. So therefore then I will turn my car and give way to the ambulance. Nowadays the siren is there, everything is there, but it is still present. You can when you go in front of the hospital, if there is ambulance, you just see how they have written the word ambulance in the front side of the vehicle. Yes, that's the only situation where there is a problem with lateral inversion. Any other situation, there is no problem with that. So I hope you all understood about the images formed by the plane mirror. If there is anything, if there is any clarification to be asked or something, you can comment below, or you can give me a call directly. In the tute, I have given that word. This is how, I hope you all can see this. This is how ambulance is written in the front side of the vehicle, ambulance vehicle, so that when I view it through a mirror, when you keep this tute closer to a mirror and view it through the mirror, it will be like this. I hope you understood.